Is time helping you right now, or should I just be going through? How many would like more time? Okay. How many of you? You say you're alone. Have you? If I lost, then I can have it. I'll wait like 2 more minutes. Or how about I go through the first one? Because you're not the first one, right? I'll go through the first one, and then I'll leave you some more time to do the second one. Okay. So again, just reviewing where I got the Venn diagram from. I started with 2 circles, and the first thing I'm putting in there every time is the overlap, because I can build out from that. So 20% take both, so 20% are in that overlap. And then I know the AP Stats circle has to be 30% large. Let me use percents here. The entire AP Stats circle has to be 30%. Well, there's already, I kind of just forget that's there. There's already 20% used. So these 2 numbers have to add up to 30 because that's the 30% that take AP Stats. And then this entire circle has to add up to 70. I've already used 20, so there's 50% left. And then these 3 add up to 80. So there's a 20% chance that they didn't take either AP Stats or MCS. And that goes like on the outside, because what if the whole box had that? 100%, right? So the probability of A given M. So what that tells you is you're only looking at the M circle. So nothing else matters. So how big is the M circle? 70%. Within that M circle, how much of it is A? 20. So that's 20 out of 7. And then you could put, you could put 2 over 7, you could put 0.2 over 0.7, you could put 20 over 70, you could divide that out and get the, it was like 0.286 or something, I don't know if anyone did that. Is that right, 0.286? Yeah. All those are acceptable, I don't care what format it's in. So let me, I didn't put this up here, but now that we've gone through that one, try this right now. M given A, so just go the other way. So M given A means we know we're in the A circle. So how big is the A circle? 30. Within that A circle, how much of it is also in the M? It's 20. So again, you can put 20 out of 30, you can put 2/3, you can put 0.666 repeating, all those are fine. 66.6%, like I don't care what format it's in. How many of them right? So probability of A complement, A and M complement. What does A complement mean? It didn't take AP Stats. What does M complement mean? It didn't take the MCIS. So they're not in either class, and what percent of people are not in either one? That's the outside part. This white part out here, that's 20%. Or 0.2. A, U, C. So what does U mean, first of all? Or, and. It means or. There's 2 ways you can do this. So you got this formula, right? We add up the 2 things and we subtract the overlap. So if I look through the wording of it, what's the probability of A? 0.3. What's the probability of MCIS? 0.7. But then that 0.2 is in both of those numbers. So we got to remove it once. And that'll give me 0.8. Well, looking at the Venn diagram, or 80%, whichever way you want to phrase that. Looking at the Venn diagram, how could I have gotten 80%? 2 ways, yeah. So that's the people that just took AP Stats, that's the people that took both, that's the people that just took MCIS. If you add them all up, you get 80%. So Cole said I just took the 20% that weren't in either one, subtract that from 100. Both are totally fine. This method of adding up and subtracting the overlap is totally fine. Don't subtract out the overlap if you're doing the Venn diagram though, because it's not on there twice. It's only on there once. So you don't have to remove it. A and C, that's probably the easiest one. Well, I want to make this stupid if you didn't get it. There's no calculations or anything, it's just what it. I guess this was probably confusing too. That should be M. That's not helping anything, is it? So what's the probability of A and M? That's just the overlap part.
Yeah.
20%. Yeah, but if I put the red line in there, it'll be helpful. Does that help? Get you back in the game a little bit, I guess. So try these ones on the bottom. I didn't add up these for you, so the very first thing you should do here is add up the row total, column total. So a lot of times they'll make you take that step, so I just want you to see it once. Probably a couple more times too, but where they don't add them up for you, it takes you a little extra work. Again, the asterisk one, you're not responsible to know yet. I haven't really taught it. Kind of, but not really. Let's see what this one is. Alright, that was annoying. Four half letter there. That could be one of them. After that, could be wash my car. Don't spell it. Thanks, man. Ready or not yet? Anyway, first person says sounds like. Okay. No offense. So Democrats given mail. So far, I know is true. So I'm only looking in this male column. So I'm basically trying to forget everything over here. So in the male column, how many people are there? 80. How many of those are Democrats? 30. 30 out of 80. So then the second one I'm saying, what's the probability of D? That's just overall. I'm not saying given anything. I'm just saying, okay, there's 70 Democrats. There's 160 people. 70 out of 160. So this question is going to be, we're going to start talking about this more and more. I will spend more time on it than just this, but if D and M are independent, then knowing one of the things doesn't change the probability of the other thing. Like if I knew the first coin flip was heads, does that change the probability that the second coin flip is heads? Not at all, because they're independent. They have nothing to do with each other. If I know the weather outside is 50 degrees, does that change your probability of guessing correctly on a Calc 4 exam? Not at all. They have nothing to do with each other. So if these two things have nothing to do with each other, giving you this extra piece of information wouldn't change the probability. If these two things are independent, these two answers will be the exact same. That would mean that, they're male, great, I don't care, it's the same answer either way. Well, these are not the same answer either way, because this is 0.375, and this is, I don't know, a little bigger. Everybody get the decimal there? 0.343. Okay. So if I just say what's the probability of a Democrat, it's 0.4375. If I tell you, well, now I know I'm only looking at males, did that change the probability that they're a Democrat? It did. It lowered it a little bit. So that means they're not independent. And you're going to be asked to prove that. Prove it is or isn't. And what you're going to say is no, because the probability of a Democrat given male is not equal to the probability of Democrat. If they were independent, these two things would be the exact same. And that's up here. To prove independent, here's how you do it. We'll spend like a day on this. But I'm just trying to introduce it now, because it's kind of hard for people, so I'm trying to slowly leak it in there. Let's move on though, because that's not the main focus of today, really. Probability of Democrat complement. Well, what's Democrat complement in this situation? Republican, right? There's only one other option. So the probability of Republican would be 90 out of 160. Probability of male or Republican. So this is that formula where you're going to subtract out the overlap. And some of you might not necessarily need the formula to do it, but I'm going to write it anyways. Where I'm adding up male plus Republican and then subtracting the overlap. So how many males are there? 80. How many Republicans? 90. Well, that's 170. The probability can't be 170 out of 160, so I'm obviously like missing something somewhere. And what I'm missing is that these people have been counted twice. This 50 was in this 80. This 50 was in this 90. I don't want it counted twice. I just want it counted once. So I'm going to go 80 plus 90 minus 50, so that's 120 out of the 160 people, which you could reduce to 3/4, 0.75, or 75%. Those are all. Does that make sense how I'm getting that? And then F given R, so female given Republican, so I'm only looking at Republicans. So I'm only looking here. How many Republicans are there? 90. How many of them are female? 40. 40 out of 90. It's a handy little thing to cover up. Questions about those at all? Did I get better? Like, did that help since the beginning now? People look pretty confused again. Alright, let's take out that packet because we didn't quite finish it yet. And just more of the same stuff, really. So on the first page, we did the first two, and then the bottom one we didn't do yet. So I want you to do that now. So I wrote some, there were no questions on the packet, right? But I wrote some questions. Again, the table is not totaled up, so I should probably do that first. Try those questions. Does anybody, I think, what girls' sports right now? Just basketball. That's it? Swimming, girls swimming in the fall, right? Bowling. Does cheerleading in winter, like, did I go both? Or it's done? It's just fall. They don't cheer for basketball games anymore? I neither. Don't visit joined up with another school.
I don't know, I saw a picture the other day. I was like cheering on our Milo book, but like 100 people. Oh, so cute. Yeah, there's like that walking team, but it was like a Milo book at the school.
Yeah, I think I'm gonna like Mile and Hand, like in Hand. So
Yeah,
like,
it's like a bunch of so
it's what? That's who we would, like, if you played hockey here, you play it here. Alright, let's talk through these. So, liked academic reading or liked recreational reading. So what you'd be doing there is adding up all the people that liked academic reading plus all the people that liked recreational reading. So now we're at some gigantic number, way bigger than 200. So 152 plus 176. But then these people have been counted twice, right? So we gotta subtract out the 136. That gives me 192 out of the 200. And think about another way to get to that. Who's the only people that didn't like one of those? These people, right? Like, they didn't like either. If you take 8 away from 200, what do you get? 92. So let's go. Just maybe another way to do it, or maybe a way to check. Like, okay, that makes sense. I feel good about my answer type thing. Liked academic reading and didn't like recreational reading. So that's just looking at this one number in the chart. That's 16 out of the 200. Probability of didn't like recreational reading, given that we didn't like academic. So we're crossing off this one. So we know that we didn't like academic. So how many people didn't like academic reading? 48. And then how many of those didn't like recreational? Also, it's 8. So it's going to be 8 out of 40. Again, you can reduce that, make it a decimal, make it a percent. Doesn't matter to me as long as you have that number. Yeah. Okay. Probability of liked recreational reading complement. So that's if you didn't like recreational reading. So 176 out of the 200 did like recreational reading, and then 24 out of the 200 did not. Probability of disliking recreational reading. That's the exact same. These are the exact same question, I think. Those two. That's 24 out of 200. And then this is that new stuff I started to talk about. Are DRR and DAR independent? Well, up here, we did the probability of DR. Well, let's start here. But right here, we did the probability of DRR. Let's make that a decimal. 0.12. Up here, I did the probability of DRR if we know DAR. And if DAR has no impact, what would this answer be? It would be 0.12 if it has no impact. That would mean they're independent. But I'm pretty sure that's not 0.12. This is like 0.167. So no, they're not independent because, right. But because those two aren't the same. Yeah.
The second one?
This one?
Yeah.
Yeah.
I don't know what I think I added them and then told them out of 200.
So if it's ands, you're just looking at where they overlap. So liked academic reading is here, disliked recreational is here, and the only one that's in both of those groups is that 16. You know what I'm saying?
Yeah.
Like, I don't know what you did, but does that help with what I did? Alright, let's jump ahead to the Venn diagram ones. Try these. easier? Is it making more sense? Ish. So, yeah, so that's. What's up? So there's no overlap there, right? So those would be what's the two word? What's the word? That's if they don't actually.
Oh, so.
Or so the C word. Jumped. Hold on. I put an appropriate word. It's like a carry away. Don't fix this today, but I see 3 phones in the caddy right there, and I count more than 3 people in the class. So what's the probability? Did it? The what? Oh, the sophomores up in there? Given you're a senior, what's the probability of which phone to get? 0. I don't think you're doing it on purpose. I'm not mad, but please try to remember.
Yeah.
The rules apply to everybody, not just the sophomores. So then who's the other person? There's 3. Who else is the book? You like to know. Oh no, there's 4. So who else? What? Very funny. What?
He changed the color.
No, I'm 17, but I just don't have it
Whose phone is that?
on last hour.
This is no one phone. This is not someone's in here. Oh man.
It was a girl that was sitting there. That was like,
That's her. That's Michaela Weber. That's hers. Alright. I'll give it to her. If you need her. Alright, happy sewing.
I left my phone on the cash register. I left the store. Went to go collect my phone and it was
Like freaked out.
no, I just walked in that. I think I lost something here. I put my phone down. But if you look at it right away, there's 50%. Wait, so did you get one phone? Oh, what is it? So that's not like, saw me like, took it to the house. Oh my God. Show us that picture. Where you have it.
the first, like the left hand side. How did I get 0?
For what? Oh,
Because there's no overlap between permanents. I guess what it's called, it's a perm. I don't know if people do perms anymore. There's no overlap between the permanent and the die.
I saw that.
Any other questions on that left hand side? Where'd you get this? I don't understand this one. How many got all of them right on the left hand side? Or just this one? Okay. Okay. Do you understand why it's there?
Yeah, now I do. I just did the 25. We can just say like the 5 plus 5 from like both sides of it.
I gotcha. Okay.
Yeah, so like that's what I thought.
You can just say 0. They are disjoint. They are mutually exclusive, but you don't have to say, yeah. I mean, I could follow up on a test and say, like, what does that mean is true about permanent?
Is that
You know,
you on the top?
yeah. This one? Die, given, haircut. So the haircut circle is 75 big, right? And in that haircut circle, we're going 39. Which way do we need to go? Am I good to go through the right hand side or not yet?
If it's a compliment, is it still in that circle?
Are you talking about this one?
Yeah.
So this would mean not die,
Yeah.
and it's not haircut, and it's not perm. So that's like none of those 3 things, and that's this number out here. So on the right hand side over here, dye or haircut. I'm just gonna add up the dye. So how big?
Yeah.
Okay. Dye or haircut. So I got this 5 plus this 30 plus this 35 plus this 10. I want to add up everything that's in the dye or the haircut circle. So that is 80%. That was tough with a triple. Or 0.8, obviously, is okay. So you do that, and all those up.
I just did.
I didn't hear what you said.
I did. I just looked at the numbers and said, what equals 45. I looked at the haircut and I said, what equals 0.7. I was off like 35.
Yeah, that works. What did you say? How did I get 80?
Yeah.
So I just added up anything in the dye or haircut circle. So 10, 35, 30, and 5.
I know 1.25.
5 plus 30 is 35. 35 plus 25. Or 35 plus 35 is 70. 70 plus 10, 80. So you got an extra something somewhere.
Oh, yeah.
You right? H or P, so haircut or permanent. Now I want to add up anything in either the haircut or the permanent circles. So 30, 35, 10, and 5. It's the same answer, right? It's still 80%. Haircut given permanent. Okay, so I know I'm in the permanent circle. How big is the permanent circle? 15. In that circle, how much of it is taken up by haircuts? 10. 10 out of 15. Or you can make that a decimal in percent. That's like 66.7%. P given H. So I know I'm in the haircut circle. How big is the haircut circle? 75. In that haircut circle, how much of it is taken up by permanent? 10. So you can divide that out whatever if you want. This means I didn't get a dye, and I didn't get a haircut, and I didn't get a permanent. So that's this little number on the outside. one more thing, are D and H independent? Well, to figure that out, you gotta look at the probability of D in general. And then the probability of D if I tell you H is true. And if I tell you H is true and that changes your probability, what does that mean? Independent or not? Not. And then 0.35 and 30 divided by 75 are not the same number, so they are not independent. So we got a little more of this to do tomorrow. Whoa. That's fine. It is what it is. I don't want to go faster than we can go. So we'll do a little more of this tomorrow, move on. And if we don't finish the whole chapter before your exam, I'm not going to test you on anything I've done. You know, we'll just kind of stop where we're at and test on that stuff. Yeah, it's almost like a new